Hi, my name is Jenna Hagan, and for my Fuel Science 431 project, I will be talking about anaerobic digestion. Anaerobic digestion is a series of biological processes in which microorganisms break down biodegradable material in the absence of oxygen. As we learned in class, this process is called pyrolysis. The end products for anaerobic digestion are biogas and a solid co-product. As seen in this chart from the American Biogas Council, organic materials such as animal waste, food waste, agricultural waste, or wastewater sludge goes into the digestion tank. After the processes, which I'm going to talk about in a minute, co-products such as livestock bedding, fertilizers and nutrients, and also biogas, which can be used for electricity, heating, and or fuel, come out. And then also the heat that is resulting from the digestion tank can go back in and be used in the processes. The chemical process for anaerobic digestion starts out with a bacterial hydrolysis of input waste. This just basically breaks down the waste into organic polymers. The next step is an acidogenic bacteria converts sugars and amino acids to carbon dioxide, hydrogen, ammonia, and other organic acids. Then there's an acetogenic bacteria that convert organic acids into acetic acid, ammonia, hydrogen, and carbon dioxide again. Methogens convert these products to methane and CO2, and you also have your solid co-product remaining from that. There's huge environmental significance to having an anaerobic digester, especially if you own a farm. Many farmers have to dispose of their livestock waste, which can be a huge outputter of methane and CO2 greenhouse gases, and also reduce air and water quality, odor pollution as well, and it costs a lot of money to manage this. So one way to fix all these problems is to install an anaerobic digester. Basically that reduces the CO2 and methane emissions because you're converting it into fuel, and improves water and air quality. You can actually provide a source of electricity, fuel, and or heat. You can sell this to the grid and make a revenue, or you can use it for yourself and power your whole farm. From the this Michigan.gov website, for every 100 lactating cows, 200 to 300 kilowatt hours per day of electricity can be generated, which is enough to power 15 homes. From the EPA website, you can allow for manure treatment, cost savings, nutrient conversion, odor and pathogen control, and byproduct recovery. Also, when you're talking about wastewater sludge, you can use anaerobic digestion to purify your water. There are many different applications of anaerobic digesters. They can be used for wastewater treatments as well as farms, and a couple other options as well. The first one is for farms. It's a manure anaerobic digester, which basically breaks down livestock manure into biogas for heat and electricity. There are 4 types, which are listed here. Additionally, there's municipal wastewater anaerobic digesters, which break down sewage sludge and eliminate pathogens. There are also industrial wastewater anaerobic digesters, which break down byproducts of manufacturing processes for food or soda or water, different types of industrial processes. There's also municipal solid waste anaerobic digesters, or MSW, which basically means that before the trash goes to a landfill or is sorted, you're able to break down organic parts of the waste stream before the landfill. And there are 3 types of these listed here as well. So there are a couple of cost barriers and challenges to anaerobic digestion. It is a good idea, but there are a couple expenses that you have to overcome before you can successfully run one. It requires a lot of time and high management skills to have an anaerobic digester. Basically, from this Michigan.gov website, it says that a half hour to an hour is required every day to make sure these systems are running smoothly. Being able to generate CO2 and methane, you're basically creating corrosive and dangerous gases, so those need to be monitored, and it could be a liability or danger to the farm or the area. It's very expensive. From Michigan.gov, it says that depending upon the system selected, the initial cost can range from $150 to $500 per dairy cow, or $80 to $300 per swine. And it's really only feasible for large farms, so that's greater than 300 cows. So if you're trying to get the minimum amount of cows that you need, to have a farm, you would have to spend almost $1 million to just build the anaerobic digester. It requires large land use, and there's complex government regulations due to obviously the different things that you have to deal with corrosive gases and land use and manure. And here are my references.